So what is a list in Python? A list is used for storing information or data, and you can store various data types. So I could store strings in my list. I could store integers, including decimal numbers. So you can have a list with various data types. And let's actually create a list. And I'm going to create a list called students. And this is going to be our variable. And inside this variable, we are going to store a list. And to create a list, we use these square brackets. So right now we have a list of students, but it's obviously empty. So let's put some students inside. So let's say we have a student called Sally, Mike, Bob, and Alice. So this list, it contains strings, so a list of strings. And let's actually print this out and see what we get as our output. So if we print out this list, we get Sally, Mike, Bob, and Alice. So identical to what we had up here. So now we know how to get all the elements of our list. But let's say we want to get a specific student. So let's say we want to only get Sally or Bob. How do we do that? Well, we would need to know the position of that student in the list. So what position do you think Sally is at in the list? And you might be thinking that Sally is at position 1, Mike would be at position 2, and so on. However, indexes start at position 0 for most programming languages, including Python. So Mike would be at position 1, Bob would be at position 2, and Alice would be at position 3. It might be confusing why we are starting at index 0, but I'll explain that in just a second. Okay, now we can easily access each student in our list by using their position or their index. So if we want to print out Sally, we can use these square brackets and put in our index. So if we print this out, we only get Sally. Let's say I want to print out Mike. Mike is at position 1 or index 1. So I just put 1 as my index. Bob is at index 2. And Alice is at index 3. Okay, so now I'm going to go back and explain why we start at index 0 instead of starting at index 1. So these are our indexes. And over here, what I've drawn is our list in the computer's memory. And each of these elements has their own unique address or location in the computer's memory. So let's say that Sally has an address of 200, and Mike has an address of 201, Bob has an address of 202, and Alice has an address of 203. And what we have done over here is we've created a student variable which will point to the address of our list, or more precisely, this first element in our list, so Sally. And to understand why we start at index 0, we need to understand that the index is based on the offset of this pointer. So I'll just write that over here. The index is based on the offset of our pointer. So the pointer is pointing at Sally. So what is the offset at Sally? Well, the offset is nothing because we are already at Sally. So that's why the index over here is 0. But if we want to go to Mike, we need to move 1 position. And that's why the index of Mike is 1, and so on. So that's the reason that we start at index 0. And another really important reason that we start at index 0 is because it is more efficient. So I won't get into that here, but I'll leave a link down in the description, which will be a short article which will explain why it is more efficient to start at index 0 rather than starting at index 1. Okay, here's our students list, and we now know how to access specific items in the list by using their index. So if we want to get Sally, we know that that's index 0. If we want to get Bob, we know that's index 2. But let's say we want to get multiple items from the list. And to do that, we use something called slicing. And slicing just means that we are slicing the bit of the list that we want. So let's say we want the first 3 names of the list. We need to slice this section of the list. So we don't care about the rest of it. We just want Sally, Mike, Bob. That's it. So to slice a list, we need to have a start index and an end index. And these are the values that we will slice between. And we separate them using this colon. So what would the start index be if we want to slice from Sally to Bob? Well, the start index will be 0 because we are starting at Sally. And the end index will be going up to, but not including, the index of Alice. So we're going to put 3 here. And let's print this out and see what we get. So we get Sally, Mike, and Bob. And you might be wondering why we put 3 instead of 2, because we're going up to Bob. But this last index, it is not inclusive. So the first index, the start index, is inclusive, but the end index is not inclusive. So let's go over this one more time. We're going from index 0 up to, but not including 3. So although it says 3 here, we are not including 3, we're just going up to 3. Let's take a look at another example. So let's say we want to get Mike, Bob, Alice, Harry. So these 4 names in the middle. How would we go about doing that? Well, what is the start index if we want these 4 names? Well, we want to start at Mike, so the start index will be 1. And what is the index that we want to go up to? Well, we want to go up to James, the index of James, but we don't want James. And if we print this out, we get Mike, Bob, Alice, and Harry. And the way slicing works might be a little bit confusing, but we've actually seen something like this before if you've learned about for loops using the range function. So let me write a quick for loop here. For I in range 1, 5. So we're starting at 1 and we're going up to 5. And I'm going to print I. And I'll just comment this out and let's see what we get as our result. So we get 1, 2, 3, 4. So we're starting at 1 and we're going up in ones up to 5, but we're not including 5. So there's some similarities between the range function and how slicing works. Okay, now there's just one more thing to learn about slicing, and that is that we can actually change the step that we are going up in. So far we have just been going from Sally, Mike, and Bob, and these names are right next to each other, so they come consecutively in the list. But what if we want Sally, Bob, and then Harry? Is that possible? Well, yes it is. So let's go through the entire list. So we can specify that we want to start at 0. We want to go up to the index 6. So this is going to go through the entire list. But we can also add another colon, and here we can specify our step. So what do we want to go up in? And by default, this is just 1. But let's say we want to go up in 2s, and let's see what we get as our output. So we get Sally, Bob, and Harry. So we get Sally, Bob, and then Harry. So we're going up in 2s this time. Before we move on, I just want to share a quick tip. Let's say we want to get the first 3 elements of our list. So we could put the start index as 0 and the end index at 3. So we're going up to 3. But if I print this, that would be fine. Sally, Mike, and Bob. But I could also just leave this start index blank, and I will get the same result. And this is because if you leave the start index blank, then Python will assume that you want to start at the beginning of the list. And you can also do the same thing for the end of the list. So let's say I want to get the last 3 elements of the list. So I'm going to start at index 3 and I want to go up to index 6. So the last, so up to index 6, but not including it. So that will be Alice, Harry, and James, and that's correct. But like before, I can leave this blank and Python will assume that I just want to go to the end of the list. Python has a lot of built-in methods which are really useful for working with the lists. And let's go through the first one. So we have an append method, and append just adds something onto the end of a list. So first let me create a list. And this is the list that I have here. So I have a bunch of numbers which represent ages of different people. And I'm going to append a number onto the end. So I'm going to write ages dot. And what you can see here is I have a bunch of methods that I can use. I have sort, append, extend, reverse, and all of these methods. So I'm going to use the append method, and I'm going to add the number 99 onto the end of the list, and I'm going to print the new list. And yeah, this just changed this list, so it just added the number 99 onto the end. Okay, now let's look at the insert method. So I'm going to change this to insert, and the insert method actually takes 2 arguments, and it takes a position that you want to insert a value at. So let's say I want to add at position 3, so after the 8, I want to add the number 99. And let's print this out. So now I have 3, 23, 8, then I have the number 99, and all of these other values after the 8, they've been shifted along. So this is what you can use for inserting any value that you want, and you can choose whichever index you want. So if you want it to be after, let's say, the 7, then you would just put 5 for the index, and now we have 99 after the 7. Okay, so now let's look at the extend method. So The extend method takes two lists and it just puts the values of one of the lists onto the end of the other list. So we need two lists. So let me create another list called names, and we'll just say Alice, Jim, and Sally. And what I want to do is I want to join the ages onto the end of this list. And to make more sense, I'll just make this have 3 values in it. So these correspond to each of the names. But let's use the extend method. So we're going to extend the names method and we're going to put the ages list onto the end of it. So let's print this out. And if we print the list, we get Alice, Jim, Sally, 3, 23, 8. Okay, let's cover the remove method now. So let's say we want to remove the name Alice from this list. And now I'll print the names list. And we just get Jim and Sally. So the rest of the methods are quite self-explanatory. The pop method just removes something from the end of a list. So if I do names.pop, then I will just remove Sally from the list. If you want to have a look at what each of these methods does, I will leave a link in the description below. Before we get started with the 4 exercises, let's talk about how we can loop through a list. So we have this list of square numbers, and let's say we want to loop through the list and just print out every single value. So we're going to write a for loop to do this, and I'll just write for value in square nums, so the list, and we're just going to print the value. So here value is 1, 4, 9, 16, 25, 36. So the values of the list. But now let's say that we want to get the indexes of each value. So we want 0, 1, 2, and so on. How would we do that? Well, we can use a function called enumerate. So I'm just going to create another variable here, which is going to store the index of our numbers. And I'm going to use the enumerate function. And I can also print the index and the value, so you can see both. So now we can get the index on the left hand side, and on the right hand side we have the values. Now let's talk about one more method of looping through a list. So we can write a for loop that looks something like this. So for index in, and we're going to use the range function. Okay, so what this does is it gives us the index of each of these values. So 0, 1, 2, all the way up to 5. And how it does this is it uses the range function, which takes the length of the list. So what is the length of our list? Let's figure that out. So the length here is 1, 2, 3, 4, 5, 6. So this is basically saying range 6. Because the length of the list up here is 6. So if you remember, the range function, it starts from 0 by default and it goes up to, but not including the value specified. So it will go 0, 1, 2, 3, 4, 5. And you might notice that this is actually the index for each of these values. So 1 has an index of 0, 4 has an index of 1, 9 has an index of 2, and so on. And we could do a similar thing to before. We can print out the index, and we can also print out the value at that index. So we need to access the list, square nums, and we need to get the current index. And just like before, we have the indexes on the left hand side and the values on the right hand side. Okay, here's exercise 1. So feel free to pause the video and give it a go. And once you want to check out the solution, then carry on playing the video. Let's start by defining our function. And it takes in one argument, which is the list. And over here, we are going to have a look at what we actually need to do to double these numbers. So we have a list 2, 4, 6, 8. And what we need to do is we need to loop through each element in the list, and we need to multiply it by 2. So let's start by creating our for loop. So for index in range then list. So this will give us the index of each of these values. And what we need to do is we need to access the value at that index. So list index, and we need to set this to a new variable which is just going to be itself multiplied by 2. So for the first value, it will be 2 times 2, and then 4 times 2, 6 times 2, and 8 times 2. And let's return the list. Now if I call this function, and let's just pass it 2, 4, 6, 8, and print the result. You can see we get 4, 8, 12, 16. So we have changed the list from 2, 4, 6, 8 to 4, 8, 12, 16. Here is exercise 2. So again, pause the video and give it a go. Let's start by defining our function. Sum is even, and it takes in one argument, which is the list. And what we need to do is we need to check if the total is going to be even or not. So we can do this in two ways. We can use the built-in function in Python, which will be a lot quicker, or we can do it manually, and I'll show you both ways. So first, let's use the built-in function. I'm going to create a variable called total, and it's going to store the value, which is the sum of all the elements in the list. And next we need to check if this is even or not. So if total modulus 2 is 0, this means that if we divide the total by 2 and the remainder is 0, so this modulus operator gives you the remainder, that means that it's even. So we need to return true. However, if that's not the case, then we need to return false. And let's call our function. And we'll just pass it 5, 1, and 4, and I'll print the result. So this is going to be 10, so it should return true. And if I just add 1 to this value, so 11, yeah, 11 is odd, so it returns false. Okay, now let's rewrite the function so that we do it manually without using the built-in function, sum. So everything else can stay the same. So this, these if statements are completely fine. But let's create another variable called total again. But this time we're going to set it to 0. And we're going to use a for loop to loop through the list. And what we want to do is keep adding to the total, and we're going to add the current value that we're on. So list I. So I is just referring to the index. So maybe I should rename that to index to make it clearer. So what this does is total is initialized to 0, but then as we go through the list, we keep adding to this total. So here total is 5, here total is 6 because it's 5 add 1, and here total is 10 because it's 6 add 4. So let's run this again and check that it works. So yep, 11 is odd, so it returns false, and if I change this to even, so 10 should return true, and yep, it does. Okay, here's exercise 3, so pause the video and give it a go. Okay, so for this one we just need to create a new list which contains only even elements. So here I've created a new list, and to create an empty list we just use these square brackets. And what I've done is I've looped through the original list and I've checked if the number is even, and if the number is even we just append it to the new list. So new list.append, and this is a built-in function in Python, and I just return the new list. So if I run this I get 2, 4, 6, 8, 10. And one thing to notice is that we are keeping the original list the same, but we're only modifying a separate list. So if I print out the list that was originally passed to the function, you can see that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it hasn't changed at all. All we've done is modified the new list. Here is exercise 4. So pause the video and give it a go. So first we define our function, and we need to create a new list for this. So we are leaving the original list unchanged. And what we do is we loop through the original list and we check if the value is greater than 0. So that means it's a positive number. And since it's a positive number, we need to append 1 to the new list. And next we check if it's a negative number. And if it is, we append -1 to the list. And if the value is 0, then we append a 0 to the end of the list. And we return the new list. And let's run this and see what we get. So we get 1, -1, 1, 0, -1. So 1 because it's a positive number, -1, 1, 0, and -1. That's going to be it for this video. So if you got some value out of this or you found it useful, then please consider liking and subscribing, and I'll see you in the next one.